again and then take us up into Algebra 2. So again, this should be in your Canvas module. Array is a portion of a line that has a starting point at one end and continues infinitely in one direction. An angle is formed by two rays with a common endpoint. So I'm going to call that theta. The initial side is the side that you start with in your angle. So if I'm going to rotate, this is called the initial side. And then I'm going to use a different color here. And this one where you stop rotating the angle is called the terminal side. An angle is considered to be in standard position if the initial side is the positive x-axis. Let me repeat that. An angle is in standard position if the initial side is the positive x-axis. So let's use our highlighters. My highlighter, there we go. So an angle is in standard position if the ray is the positive x-axis. The vertex is the endpoint shared by the two rays. Positive angles rotate counterclockwise. So let's draw a coordinate grid. So I have an initial side that is the positive x-axis. Positive angles rotate what we call counterclockwise. So I might say that's 120 degrees. Negative angles measure clockwise. Negative angles measure clockwise. So let's suppose I go this route. I could say that angle is negative 210 degrees. So again, positive angles go counterclockwise and negative angles go clockwise. It's kind of the opposite of what I would think. Acute angles are an angle that measures between 0 and 90 degrees. A right angle measures 90 degrees. Obtuse is an angle between 90 and 180 degrees. A straight angle measures 180. So let's maybe we can draw a couple of those. So here's a right angle and a straight angle. We do need a vertex. Again, standard position is an angle whose vertex is at the origin of the coordinate plane. So let's say I had a positive angle of 45 degrees, and then we say that the angle is in the quadrant that its terminal side is in. So 45 degrees, we would say, is a quadrant 1 angle. And do you know it goes Roman numeral 1, 2, 3, and 4. You learned that back in Algebra 1. So now we are going to be making connections to our special right triangles. Like there's always a method to our madness here. So when it says you want to sketch an angle in standard position for each of the following. If I have 120 degrees, well, and I guess I'm making an assumption that you know that it goes 90 degrees This is 180 degrees, 270 degrees, and then no rotation is 0, and a full rotation is 360. Okay, it's assumed you knew that. So I wouldn't state that. So we start 0 is no rotation, then 90, 180, 270, 360 degrees is a full rotation. I do not expect perfection, but I do expect accuracy. So 120 degrees, how many degrees into the second quadrant would I find 120? Well, I know exactly how many. 30, right? So from 90 to 120 is 30 angles. Now I want to segue back to what you mentioned, is what would be exactly halfway in a quadrant? How many degrees? 45, right? So is 30 halfway in? No. So what I mean by I don't expect perfection, but I expect accuracy, when you sketch 120, it should not be hitting halfway. Like I at least know. So our angles are going to go 30, 45, and 60 because they connect to the special right triangles. So I'm going to eyeball where halfway is and then take it up a little bit. So then I'm going to draw, and I need an arrow with a little arc, and that's going to represent 120 degrees. So make sure that you are sketching the initial side, the terminal side, and an arc with a little arrow, that because we can do positive rotations and negative rotations. So it matters. It does, in fact, matter. So now the second one, letter B, negative 120. So I need to think, now I'm going to go clockwise because of the negative angle measure. Again, I'm considering a negative angle measure as clockwise. So I think about it a moment, and rotating down to the y-axis would be negative 90. And then how much further do I go into the third quadrant? 30 degrees. That's not quite halfway. And then I'm going to draw an arc with an arrow and then put negative 120. Let me go back, and I forgot. In letter A, that was a second quadrant angle. Letter B, where is the terminal side located? What quadrant? Third. All right, just caught myself. Okay, letter C, 390 degrees. So something I want to emphasize is I don't expect you to always know exactly what to do. However, I do expect you to keep asking yourself some questions. What do I know? What can I figure out? So we just don't want to ever give up, and we don't ever want to stop trying something. So with 390 degrees, what's something that's popping into your head? Yeah. Awesome. Okay, what do we know? We know a full rotation is how many degrees? 360. So I like your connection there. I know that 390 degrees is more than one full rotation. Well, how much more is it? Take 390 minus 360, that's 30 degrees. So watch what we're going to do. That's going to be not halfway in the first quadrant, but I need to indicate that I did a full time around plus 30 degrees more. So I start at the x-axis and I draw it like this. And guess what? I'm not going to say 30. I'm going to label that 390 degrees. Does that make sense? Yeah. Okay, cool. And what quadrant is this one? 1. That's the first quadrant. All right. Well, not all angles are inside a quadrant. They have a special name. They're called quadrantal angles. And their terminal sides are either on the x-axis or the y-axis. Can you think of some angles that don't land inside a quadrant, but they land or the y-axis? Can you think of any? 90 degrees, yes, okay. Good job. So this is going to be 90 degrees. So if you were asked, what quadrant is this? We would say it's not in a quadrant. Okay, what's another quadrantal angle? 180. Negative 90 is quadrantal. Let's just try to stay positive. I get it. Stay positive. Positive angle. But negative 90, what would be its positive counterpart? Instead of rotating negative 90, yeah, 270. And that, I didn't even plant that. That's actually my coterminal angle definition coming up here. I couldn't have asked for a better example. So watch this one. So, oops, I wrote that wrong. Hold on. 270's down here, so it goes like this. What about 360? 360 is quadrantal. You understand how to draw that one? You would have the initial side and terminal side are in the same spot. 0 degrees is also. And then, do you understand that there are infinitely many quadrantal angles? Because just like Keelan mentioned, I could go negative 90, negative 180, negative 270, negative 360. But I could also add 360, add another 360, subtract 360, and I could just keep going around and around and around. So that leads me beautifully to something called coterminal angles. So here's an example of coterminal angles, 270 degrees and negative 90 degrees. Coterminal angles have the same initial side and same terminal side, but they do a different rotation. They don't do the exact same rotation. So 270, you see this one? But negative 90 also had the same initial side and terminal side. Now I'm going to give you another pair. What about 60 degrees and 420? So 60 degrees is more than halfway. So I could do 60 is just the little blue one, and my red one is 420 degrees. Again, the definition for coterminal angles, and we're going to use this in the next lesson, is they have the same initial side and same terminal side. So they can still go positive rotations. What would I have to do to get the next positive one? So I have 60 degrees, I have 420 degrees. How would I find the next one? What would you have to do? Yeah. Add 360 to it. So here's how you find them. What method? You can add, and actually I could go around the negative as well. I could add or subtract 360 degrees. So coterminal angles are going to be important. So the next example says, find the angles of smallest positive measures that are coterminal with the following angles. So if I have 900, I don't want to add 360. That's going to get bigger and bigger and bigger. I want a coterminal angle that's smaller, but not negative. So watch what we're going to do. I'm going to take 900 degrees and subtract 360. So that gives me 540. Is there one that's positive and still smaller than this? Yes, because I could take 540 and subtract 360. So 180 is this, because if I now subtract 360 again, I'm now negative, okay? So I don't want you to think that you always add or you always subtract. Sometimes you add, sometimes you subtract. It depends on what you're trying to do. So then in letter B, if I have negative 150, I don't want to subtract 360 because that's going to make it an even smaller negative. I want to get it to positive, so I'm going to add 360 this time. And so that is the smallest positive, because the next one, when I add 360, it'll get bigger and bigger. All right, complementary angles. The nice thing is you did this in geometry, okay? This complementary are two angles who add up to 90. So complementary examples could be 30 and 60, 45 and 45, but it could also be 10 and 80. Those all add up. And I had, this was probably 20, 25 years ago, I had asked a more experienced math teacher than I was and said, you know, students can't seem to remember which one's complementary and which one's supplementary. And he said to me, he said, it is right to give a compliment. Now that was C-O-M-P-L-I, like saying, oh, your hair looks nice. That's a compliment with an I. But it was kind of helpful. So if that helps you remember, complementary add up to 90. Supplementary are two angles that are positive. Okay, we do need to say that they are positive. Two positive angles. Yes, let's clarify that. So they do have to be positive angles. Add up to 180. So I could do 30 and 150. I could do 45 and 135. I could do 60 and 120. I mean, and there's just a whole bunch of them, right? All right, that finishes up today's notes. Go ahead and go to Canvas, and I want you to pull up. It is the 7.2 Day 1 worksheet. Wow, we have 10 minutes? That's weird. Okay, we never have that much time.